Okay, welcome. We are doing a practice test today. I have gotten some comments from in the past that I've been too quiet, so right now I'm blasting music in my ears so that I have to talk louder to be able to hear myself. So, if sometimes I say something stupid or I get lost, blame my sixth period for telling me I'm too loud, and it's all their fault. Anyway, let us start. The first thing that I'm going to say is that let me pull up my formulas real quick. I have the formulas down at the bottom. I'm not going to be scrolling back and forth because that's going to give you guys a headache, so I'm going to pull them up on my laptop. For 1 and 2, we're going to find all solutions of the equations on the interval. So this is just on the interval. This is not all solutions. You're not going to go with plus 2 pi n here. Absolutely not. Just on the interval. So, cosine of 2x, let's rewrite this. I even tried to save the file this time and bring it into Notability, and it didn't work. It still looks gross. So we have cosine of 2x and sine of x, so our issue here is that we're going to have a 2x here and an x here. We can't combine those in any way, so I want to change this 2x to just x, and we could do that using the double angle formulas. And cosine, if you remember, has 3 double angle formulas. There's one with a cosine squared, a sine squared, one with a cosine squared, and one with a sine squared. So I'm going to change it to 1 minus 2 sine squared of x plus sine x is equal to 0. Rearranging this stuff to sine of x squared plus sine x plus 1 is equal to 0. I'm going to have to pull a negative out of here. Sine of x squared plus, nope, this would be minus. So this is in the form 2x squared minus 1 minus 1. Oh, excuse me, minus 1. This is minus x minus 1. So we need two numbers that multiply to negative 1. So it's going to be a 1 and a 1, and we want it to be more negative than positive here, so the 2 is going to be the more negative, the outer. It's just factor. You guys could do whatever type of factoring, whatever form factor you want. I haven't seen half the stuff you guys are trying to factor using. I just kind of think about it because I've been doing it for so long. I don't even remember the method that I was taught. So we're going to be left with, and this is replacing x with sine of x, so we'll just plug sine of x back in. We should plug it back in. Sine x plus 1, sine of x minus 1, and that's equal to 0. We have the zero product property. So we're going to have 2 sine x plus 1 equal to 0, then sine x minus 1 equal to 0. On the left, it's fairly simple. We're going to get sine of x is equal to 1. That is only going to happen at one place when the y is equal to 1. So this is at pi over 2. Over here, we're going to subtract 1 divided by 2 and get that the sine of x is equal to 1, or negative 1/2. And when the y is negative 1/2, that is going to be at pi, nope, well, it will be pi. It's over 6, 11 pi over 6, and 7 pi over 6. I hope that's right. That sounds right. I think we're good there. So these are your answers. X is equal to this, and x is equal to that. Remember, just on this interval. Next up, we got tangent of x over 2 minus sine of x is equal to 0. This is going to gets fun. Oh no, I gave you guys a gross tangent formula, one of these ones I don't like. I'm gonna have to go back and change this to what we were given in class. Oh, that's quite annoying. I need to make sure I'm gonna do that right. Half angle formula. I believe it's, yeah, when you're doing sine over cosine, it's a plus. So we want to change the same deal that we wanted to do over here. We're going to do the same thing over here. We want this x over 2 to look like x. We have a formula that would change tangent of x over 2 into sine over 1 plus cosine x minus sine of x is equal to 0. We have a common factor of sine of x in both of them. So I'm going to pull that out. And we're going to have a zero product property, so we can just deal with it like that. So we're going to have 1 plus cosine of x minus 1 is equal to 0. So sine of x is equal to 0. 1 over 1 plus cosine x minus 1 is equal to 0. Let's do this one first. Sine x is equal to 0 when x is 0 and when x is at pi. Remember, we are including 0 with the square brackets and not including 2 pi. So that's why I'm writing it like that. This side, we get 1 plus cosine x. If we multiply the cosine, or 1 plus cosine x to the other side, we are going to get 1 over 1 plus cosine of x. And then this just becomes 1 right here. And then if you subtract 1, it's going to become 0. So cosine x is equal to pi over 2. Well, cosine x is equal to 0 at pi over 2. And 3 pi over 2. Fine and dandy. Let's move on. Find the exact values. So for this, I don't know what the sine of, oh my goodness, 112.5. That's a 0.5 right here. Sine of 112.5. I don't know what that is, so I need to use either a double angle or a half angle formula to help solve that. So when doing those, you need to set what's in the middle equal to a double angle or a half angle. If I use the double one, I'm going to get something gross. What is it going to be? I don't know. What's going to be 50 something? 56.25? That's not on our unit circle. But if I multiply over here, we're going to get 225 is equal to x. So I can solve this by saying sine of 225 over 2. And those are equal to each other. So this now is going to equal plus or minus radical 1 minus cosine of 225 over 2. Let's kill two birds with one stone. Our sine here is at 112, so that would mean it's going to be positive. Solving for cosine of 225, where's 225? That's going to be a negative cosine. So 1 minus square root of 2 over 2, all over 2. This radical goes down. In simplifying, we need to multiply by a nice little 2 over 2. We've done a few of these in class, so I'm not too worried about your guys' ability to simplify this down. This is going to be all over 2 because you're going to get a 2 times 2 on the bottom, square root of that. The square root is only on the top in this case, and we're good to go. You cannot simplify this. Some of you will sometimes be like, oh, there's a 2 on the top and the bottom like that. Cross it out. No, there's so many reasons why you can't do that. 1, it's under a radical. And 2, you need to factor out here. You cannot cancel like that if they're not being multiplied. Gonna make me cry out here. Next, 7 pi over 12. We're going to do the same exact thing. 7 pi over 12 is equal to 2x. If I multiply this then by 2, We get 14 over 12, 7 over 6. Is that right? No, this would be divided by 2. No wonder I'm not right. And that doesn't simplify, so if I said 7 over 12, so pi over 12 equal to x over 2, we multiply, we're going to get 7 pi over 6. And we are good to go. So we are going to set up the oops, that was gross. The tangent, 7 pi over 6 over 2, and that's equal to that, which is just quite simply a true statement. Let's make sure, let's see, which one do I want to use? I'm going to use the half angle formula with the sign on top. So 7 pi over 6 over 1 plus cosine of 7 pi over 6. 7 pi over 6, the sine of that is going to be negative 1/2 over 1 minus radical 3 over 2. If I multiply the top and the bottom by 2, that'll get rid of both of those fractions that we have going on. So I'm going to get negative 1 over 2 minus radical 3. I need to now simplify this once again. I'm going to multiply by the complex conjugate. Wait, hold on, let me make sure I'm actually doing this right. Plus. Yeah. Let's make sure this is right. So we're going to get over 2 times 2 is 4. It's going to be plus radical, or excuse me, plus 2 radical 3 minus 2 radical 3 emails minus 3, which is going to equal to negative 2 minus radical 3. Those cancel out over 1, and it would have been more beneficial to keep that negative out in front. All these negatives cancel out. You can factor it out at the top, and you're just going to be left with 2 plus radical 3. There. Great. Use double angle formulas to rewrite the expression. So this is going to be thinking backwards. You're just going to look at your double angle formulas and see, what can I do with this? What does this look like? So this almost looks like the sine of 2x is equal to 2 sine x cosine of x. We want this to look like that. And how we do that, let's start this in red. Let's just use a pretty color. Let's use magenta. So we have this sine x cosine x. We need there to be a 2, but to just put a 2 in there, we can't just do that. If we multiply it by 1/2, 2 times 1/2, like 2 times 1 over 2, that's equal to 1, so we could just throw that in there. Now we know that this looks like that. So we're just going to get 1/2 sine of 2x, because this here is the same thing as that. So that one is fairly simple, straightforward. Next, we got a 10 and a 5. So what are we going to do? Let's factor. Factoring will never, ever, 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 ever escape you in mathematics. If you don't know how to factor, you should figure that out. Alright, so we have one more issue here. We have an issue that I wrote the wrong thing. We, in the formula, have 1, so our formula says 1 minus sine or 2 sine squared of x. I have a positive sign and a negative 1. So if I just pull out a negative, I'll have what I got in our formulas. And I know that this is equal to cosine of 2x. Wonderful. This inside that is equal to cosine of 2x. We just simplify and throw that back in there. Oh, okay. So in this case, we got, a little complex situation. It's almost going to be like reverse factoring. We have cosine squared of x minus 1/2. We want it, let's do it in red, to look like 2 cosine squared of x minus 1/2. Nope, minus 1. I blame it on the music. I got a banger playing right now. How we make it look like this is we have to pull a 1/2 out. If I pull a 1/2 out of all this stuff, let's imagine I do that before factoring. We're getting 1/2 times 2 times cosine squared of x minus 1/2 times 1, get 1/2 cosine squared x minus 1. And then once again, oh, I forgot the 2. This then again equals our 1/2 cosine of 2x. So, there we go. Wonderful. We're almost done. Oh, maybe not. Oh, maybe not. Oh my goodness, I'm going to be here for a minute. That's so sad. So, find the following given the information. Secant is blah, 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 where blah is in quadrant 3. Cool. Let's draw a triangle, because I give you a quadrant. So that means you should probably be drawing a triangle. And if you don't, you probably should. It's just going to help you out. So secant is cosine, so this is really what, our hypotenuse over cosine adjacent. So our adjacent up here is 3. Our hypotenuse is 5. We're negative. So our other side is going to be -4. Great. Let's keep on chugging. So I'm going to move this over here so I can just zoom in. So we're going to get the sine of 2u. So this is going to equal 2 sine x cosine x. So 2 times, what, -4/5? And then -3/5. So this is going to equal 24/25. That looks right. Seems right. 2 times 3 times 4 is 24. 2 negatives cancel out. We're calling that good. Alright, u/2. So this is going to be plus or minus square root 1 plus the cosine of x, which we said was -3/5. So I'm just going to subtract that over 2. On the inside, we're going to multiply by 5/5 to get rid of this denominator. As we keep it moving, what we have to think about with the positive or negative is what quadrant we're in. We are in quadrant 3. So that is going to be a negative for the cosine and the sine. Keep on moving. Square root 5 minus 3. No. We're having a breakdown. Oh, that is so bad. I don't want to have to do this twice. 2/10 is equal to negative square root of, or this. So -√5. Nope, that's a 3. Oh no. I'm crumbling under the pressure. Maybe if my pen dies, I'll tell a story or something like that, so there's not some awkward weirdness. Tangent u/2 is equal to the sine, which we said was -4/5 over 1 minus 3/5. Same thing I did with the last one. I'm going to multiply by 5/5. So I'm going to get -4/1 minus 3. Negative 4 over negative 2, and that is going to equal to positive 2. Negatives cancel out. 4 divided by 2 is 2. Look how easy this is. You guys are going to get this and be like, oh, there's so many different parts, and you just have to like plug stuff in, and the rest. So we know that secant of 2u is equal to 1 over cosine 2u. So let's just find the cosine of 2u. Oh, cosine of 2u. What's the best way to find it in this case? Let's do... and finding the cosine of 2u. Ironically, it's just probably going to be easiest to do negative 4 over 5 squared minus negative 3 over 5 squared. And that's going to be from this, so that you know what I'm doing. If I square 4, so we're going to get 16 over 25 minus 9 over 25. So we are going to get 16 minus 9. I just had the biggest brain fart ever. I wanted to say 5 so bad, but that would have been wrong, and I would have got roasted. So let's just think through things here. Like I said, music's blaring, so I can talk loud, and my pen's dying. Great. Use law of sines, if possible, to solve the triangles. Oh, I'm going to need my calculator. Should have come prepared. Let's actually, so we got Q. Angle Q is equal to 25 degrees. Side Q is equal to 4. And Z is equal to 6.2. So let's actually draw this triangle slightly more proportional. If our Z is longer, that's going to be our side here. So we're going to have 25 degrees, 4, and 6.2. Alright, let's grab the calculator. So we have two sides and an angle, and we're going to use law of sines here because that's by far the easiest thing to do, and that's what the directions tell you to do. So we're finding, start color coding stuff to make it look fun. So we're going to find the sine of B. That's going to equal the sine of 25 over 4, and sine of B is over 6.2. So our sine of B is going to be sine 25 parentheses times 6.2 equals divided by 2. No, it's divided by 4. Oh no. Divided by 4. So we're going to get 0.6550558 something, blah, 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 blah. Just take the inverse sine of that whole entire answer. Don't simplify until this point. So we're going to get B is equal to 40.924. And we could stop there. Our angle C, so C is going to equal 180 minus 25 minus 40.924. So 180 minus 25 minus that answer. So we are going to get C is equal to 114.0759. Beautiful. Beautiful. Lastly, we got to find our side C. So our side little c. So we're going to set that up. Sine of 114.0759. That is going to equal to, what are we doing? Let's go sine of 25 over 4. So especially in this case, because if you round a bunch of times, it's going to make it less accurate. Just write out this work, sine of 114.0759, and then just go to your calculator, type 4 times the sine of whatever that angle was, because the answer's already stored in your calculator. It's in the answers, and then and then divide it by the sine of 25. What are we getting? Ooh, does this answer make sense? Let me make sure we got all my work correct. 4 times 7, yep, looks correct. So we're going to call it correct. So we get little c is equal to 8.641. And we're good to go. We got A, we got B, we got C, we got all the sides. We're good to go. Great. Solve the triangle. We are given angle B. We're given A and we're given C. Oh, but let's note one thing. We are given an obtuse angle. So let's draw an actual obtuse angle. Our angle is 150. That's B. So our angle B is equal to 150. Our side A is equal to 10. Our side C is equal to 20. So we get I know what's going on. So 10, we'll call that there, and then 20. And we're just, solving the triangle? So in this case, we don't have any pairs. So we are going to have to use the law of cosines. I am going to start by finding a side, because to find an angle using the law of cosines, you need to actually have all 3 sides. So let's just pick an angle. Let's pick this one. So this is going to be angle C. So no, I literally contradicting myself. We need to let's find side B. Sorry. So side B. Side B squared is going to equal to A squared plus C squared minus 2AC times cosine of B. If you guys haven't noticed when you're doing this, if you're finding the side length and you're forgetting how to use this formula, the only other time that the side length, that B, is going to pop up is with the angle. That's the only time that B comes up. All the other stuff here, that is the other side lengths. So that's just how I think about it. Okay, let's start plugging some stuff in. A and B are 10 and 20 respectively. Or maybe not. Yeah, so 10 squared plus 20 squared minus 2 times 10 times 20 cosine 150. I'm going to type every single part of this into my calculator straight away. I'm not clicking enter. I'm not clicking enter once. And this is kind of a downfall of the iPad. I can't show you exactly what I am plugging into my calculator. But we are going to get B squared. I really hope that this auto brightness thing doesn't show up. If not, I just flashbanged you guys and I apologize. But see, it's on this auto dimming stuff. So B squared is equal to 846.4101615. Second square root. Take that square root, and what do we get? 29. Does that make sense? Yep, pretty much. B is equal to 29.093129111. Why would you round if it takes you 3 extra seconds to write all those numbers down? Now we have all 3 sides and an angle, so I am going to start using the law of sine to solve for the sine of C. So sine of C over 20 is going to equal to this number on the bottom. Yeah, that makes sense. So 29.093129111. I want to make sure I actually did this right. If not, all of our numbers are going to be off. Let's just throw this in parentheses just in case. Nope, we're good. I hope. Knock on wood. and this is going to be cosine of 150. And isolating the sine of c, we're going to have the sine of 150 times 20 divided by that 29 point whatever number. We're going to get the sine of c is equal to 0.3437237,694. Take the inverse sine of this, and we're good to go. We get c is equal to 20.103900937. Great. So this is our angle for c. And then all we do at the end is we start subtracting stuff from 180. So 180 minus that angle minus 150 is going to give us our, let's use a different color so we know what's going on. Let's use this blue, our last angle. So this is going to be angle A. So angle A is going to equal 180 minus 150 minus 20.103900937, and that will equal 9.8960963 degrees. Great. And we are good to go on that front. Let's look at our next problem. So you might have PTSD from doing this way before. This problem, it's gonna look like this. It's that problem where there's those two cars approaching the mountain and we all struggled on how to figure it out. The law of sines and cosines makes this problem infinitely easier. So distance, the first distance is 17, the second distance is the angle is 1731, 50 meters closer. So this here is 50 meters. This is 17 degrees. This is 31 degrees. We want to find the height. I worked this out earlier in my head. We can start filling out a bunch of these triangles, and it's going to help us get to the answer. So what we can do is we can make one big triangle up here. So I'm going to try to be very color conscious and work with those colors. So that angle up there is going to be 180 minus 90 minus 17, not 14. 17. And we're just going to call this the purple angle. Or let's call it angle Q. Why not? That's going to be 73. This little green angle is something that we can figure out, but we need to figure out this angle first. So this is going to be 180 minus 31 degrees. So this is 149 degrees. This angle is now 180 minus 49 minus, no, it's 149 minus 17. So that angle is 14 degrees. And lastly, 180 minus 90 minus 31. That's going to be 59. So now we got 8 billion different things in this problem. What do we do? Our big issue here in solving is that we don't have this length, which is unfortunate, but do we really need it? Our end goal is to just find this height, so we need to think about a way that we can find that height given our circumstances. A few other things that we can do is we can solve in this triangle. I don't know a real clear way to solve for this, but I can solve for this side. I have a side length, and all the angles necessary to be able to do that. So let's go ahead and solve using our law of sines. So we're going to have 50 over sine of 14 is equal to, let's call this m, why not? M over the sine of 17. So multiplying that sine of 17 over the other side, we're going to have sine 17 times 50 divided by sine 14. And we are going to get that m is equal to 60 point. It's still stored in my calculator, but I'm going to round in this case because I ran out of room. Now, to find that height, I can just use SOHCAHTOA. So I can set, we'll do it in black since our h is in black. We can set the sine of I just had another brain fart. Sine of h over m. So we're going to multiply that m over, and we'll get our h. So it's going to be that m that we had. I'm just going to bring that answer directly down, no rounding at all. And then the sine of 31 degrees. So we're going to get our height is equal to 31.1. So this is our final answer, so we're allowed to round this a little bit. So 31.122. And that is our final height, it looks like. One more. Uno más. So we got this triangular parcel of lands with side lengths of this, that, and the other thing. Let's find the measure. Oh, all we're doing is find the measure of the largest angle. Oh, come on now. This is too easy, my friends, too easy. So we have our wonderful property in math and geometry that the largest angle, or like the angles in the sides are proportionate. So the largest angle is going to be across from the largest side. So we're looking for this. We don't have any other angles, so we're going to have to use our law of cosines. We're going to have to use this one. So we're going to get 650 squared plus 575 squared minus 725 squared over 2, 650, and then 575. When I'm typing this into my calculator, I put the entire top in parentheses. So 650 squared plus 575 squared minus 225 squared parentheses divided by parentheses 2 times 650 times 575 parentheses, and that is going to give us point. So this equals 0.30434782661, and we're still taking the cosine of this, so let's just call it A. So A is going to equal the inverse cosine of that angle, which is going to be about 72.28106813 degrees. You could have rounded that, but I don't know, I just wrote it all down. So that is our practice test. I hope everyone had a thoroughly enjoyed their time listening to me babble on about math. Let's see. If you made it all the way to this point in the video, should I give you a hint for the test? Yeah, sure. 1/2 base times height, and then I'm just going to erase it.